The next thing we're going to simulate now is another very common action that happens every time that teams need to upgrade the cluster to a new version of the upstream Kubernetes. We have seen in previous commands, and I can run it again, that we are running version 1.8.2 of Kubernetes. So if I just run again kubectl get nodes, we are going to get the information that I was referring to. So each node is running, and the master is running also 1.8.2. So what I'm going to do is I'm going to upgrade the release of CFCR, which essentially comprises Kubernetes, to a newer version that is going to bump Kubernetes version up to 1.8.4. So the approach to do this is similar to what we have done before with the stem cell. The difference here is that instead of upgrading the stem cell, I'm going to upgrade one of the BOSH releases. And then I'm going to let BOSH apply that new release across all different instances of the cluster. So the first thing I need to do is I need to upload that new release to the cluster. And I'm going to do that running a command that is going to pull that release from the cloud storage and is going to upload it to BOSH. So now that we have the new release uploaded, we can confirm that it's also available for us to use. So I'm going to run BOSH releases to get the list of releases available, and we can see that for the Kube release we have two options. The older one, 0.9.0, which has a start, that means it's the one active in one of the deployments, and 0.10.0, which is yet not being used. Now the next step for us is to deploy a new version of the manifest that uses this new release, and also since it's an interesting jump from version 0 to 10.0, we have additional changes in the manifest that are to ensure compatibility with the newer version. So I'm essentially going to use a new manifest, and there's also one important aspect of this manifest. We are going to expose a property so that we can pass a parameter in command line to, for example, dynamically set the number of workers. So what I would do normally now, which is BOSH deploy CFCR, and then this new manifest is called 10. I'm going to do something slightly different. Instead of passing the manifest itself, I'm going to pass a transformation of that manifest. And that's going to be using the interpolation capabilities of the BOSH CLI, using the CFCR10 as base manifest. And we're going to pass a variable name, which is worker count equal 3. Okay? We're going to keep the same number of worker nodes for now. So since with the update of this new release, we have a few other releases that need to be upgraded to be compatible with the new Kube release. That's what the new manifest also contains, and that's what BOSH is detecting right now. It has detected that additionally to that release that we manually uploaded, there are other things that have changed, and it's basically showing you that you can let BOSH download those things automatically, or you can do it manually as we did before. So now we need to wait for those releases to be downloaded, and then the changes will start happening. Now, after that new releases, those new releases that were necessary have been downloaded by BOSH. BOSH is prompting us again to confirm if we want to go forward with the changes, and it's telling us what things have changed, what things have been added and removed. But there are a few things here. The most interesting ones are the ones that are on the top. This is essentially the one that we were purposely trying to change. We are using version 0.10.0 of the Kube release, which is the CFCR release. And this is another release change that we have observed. Now we are using this version of etcd that is newer than the older one that we're doing. And then there's a few other changes that pertain to new features and capabilities of this new CFCR release. And we are obviously not just changing that release. There's additional changes that were included when bumping from 090 to 010. So BOSH is detecting all those changes and telling us to accept, which we are going to do it. Click yes. And the deployment is going to start in a moment. But since we have upgraded a few releases, there is new packages that need to be recompiled for the new release. Now that the compilation has finished, BOSH is capable of continuing with the process and is going to be updating all instances of the cluster. We have basically changed the version of the CFCR release to a newer version, and that pretty much affects all instances in the cluster, both masters and worker nodes, since we are redeploying Kubernetes and adding other changes additionally to that relate to new features of the CFCR release. So the process that is going to happen right now is very similar to what we experienced during the stem cell upgrade. BOSH is going to try canary deployment on each one of the instances first, and once that canary works fine, it's going to continue with the remaining instances of the group. First with the masters and then with the workers. During that time, same rules should apply. Your workload should not have any downtime unless the worker that is affected is the one where you're running, in this case, the Redis master. So if I refresh this case, even if one worker node is being updated, I have no downtime. This is likely because one of the other worker nodes is being updated right now. So let's clear this screen and let's run our long watch command to see what's going on. So we have here how one of the worker nodes has been updated and is going to be out of not decommissioned, but not available for scheduling. While the update of that worker happens. Because that worker was affected, Kubernetes detected some things that needed to be evacuated and moved to another worker node. And that's what happened. That's why we have a couple of pods that are now restarted. And now that that node is back, we see that he has upgraded the version from 1.8.2 to 1.8.4. And BOSH likely has moved to the next worker. There we go. One worker is done, and the next worker is coming up. So same thing will happen. In this case, we see that the Redis master is one of the pods that is affected. So it's going to be out of unavailable for a moment. So in this moment, if I try to refresh this, is probably gonna give me no messages because it cannot read from the Redis data store at that time. Once this is back in place, it should reattach the volume to the new node where this pod is running, and we should see the messages again. Now we have it back running. One of the nodes is still in the works, but I should have all my messages back here. There we go. That is correct. And while BOSH continues fixing this, the moment that it finishes, we should see that that node is back schedulable and with a newer version of Kubernetes. So let's give it a few more seconds. We see that the new version is already applied, but still the node hasn't been flagged as scalable. And now it is. So now 2 nodes out of 3. If we check the BOSH output, we can see that the second node has already finished and is continuing with the third node. As you can see, this is following this rolling upgrades approach, so that one node is down at a time. After the canary is done, you can actually change that behavior and deploy more than one instance at the same time. But for our demo purposes, we are doing one at a time. Now we have a third node going down. In this case, none of the pods is being restarted because none of the pods were running there. After all the updates that we've been doing, we probably don't have the best distribution of the pods. After the stem cell upgrade and the Kubernetes upgrade, it looks like 2 pods at least are running in the same node, and there's one node not running any pods. And now we see how this version has been bumped as well, and the third node is back available for new scaling. If we go and check the BOSH console, we can see that the upgrade process has finished. So now the next steps that we're going to do is scaling the cluster from 3 worker nodes, which is the current number of nodes, to a higher number of nodes. For example, 4 worker nodes. And I'm going to use one of the features that I introduced in the previous test, which is passing in command line a value that we have previously placed in the manifest to control the number of workers, so that with just one command I can switch from, in this case, 3 worker nodes to 4 worker nodes, and potentially programmatically make these changes based on needs to increase the capacity of the cluster or decrease it. So I'm going to repeat one of the commands that I ran before. Now instead of saying worker nodes count 3, I'm going to say 4, and I'm going to redeploy again. The only change that is detected is the number of instances. I'm going to say yes, and basically what's going to happen after is the number of workers is going to be processed by BOSH. It's going to detect that it needs to deploy one new instance, so it's going to create that new VM, and it's going to install all the worker node processes and software that is required, so Kubernetes, proxy, etc. But also, since this is part of the cluster, it needs to update all the other components so that they are aware that there's one more worker node. So if I click yes, the process is going to start. In this case, we shouldn't see any compilation because there is no change in versions or new packages. The first thing that's going to happen is the creation of the new VM. So BOSH has finished now the redeployment process, and we have 4 workers available. We should be able to check that. Let's go into the other console and see how we have one more worker that has a younger life, and it also has the latest version because we used the latest version of the manifest, which was already pointed to the latest version of the release. So with a simple command, we have basically scaled the cluster from 3 worker nodes to 4 worker nodes. The next thing we're going to do is to test and demo BOSH monitoring and self-healing capabilities. In a very similar way to how Kubernetes manages self-recovery for all the pods and containers that are running in its cluster, BOSH also checks that the state of the cluster is always a desired state. So for example, if one node happens to have a problem because of an issue with the underlying infrastructure and the VM fails, we will have BOSH recover that instance, that VM, when it detects that the desired state is not equal to the current state. At the same time, thanks to the agents that get installed on every instance, as they are part of the stem cell, BOSH can check that all processes that are executed are running at any time. And if something is not running at process level, it will restart it. So what we're going to do right now is to create a problem by accessing the vSphere console. I'm going to delete one of the worker nodes, and then we're going to see how the cluster tries to recover itself. We're going to see definitely both Kubernetes trying to fix things around, and BOSH will try to fix the instances. So let's select one of these worker nodes, and let's kill it. Let's just power it off. So we have power of the machine. If you go to the list again, we should see one that is powered off. Now our friends should start detecting that there's a problem, that one of the VMs is not running. Let's run a command here to check all the VMs that are available according to BOSH. You see that this command is taking a little bit long to respond, and that's because BOSH has already detected that something's going on, and it's probably taking steps in order to notify of the problem so that it can be fixed. As we can see, one of the worker nodes is unresponsive, and if we check here, we'll see that one node is missing, and Kubernetes is very quickly recreating the missing pods that were running in that node, and is likely deploying those pods in one of the existing available nodes. We have 3 available, so it will schedule those pods to run in those other nodes. Let's take a look again at what BOSH is doing. So what's happening right now is that the problem has been detected. It should be notified internally, and first BOSH has removed records from its metadata about the node that was running. And if we actually check all the events that are going on, so the last 5 events, actually they're in the opposite order. So we can see here how the health monitor is notifying the director that it needs to recreate this instance. And the previous instance that was running there has timed out. So things are in motion. It's going to take a few seconds for the director to try to recreate that VM. Let's keep checking the amount of VMs that are here. We have now 4 workers. It looks like the new node has been created, so from through here we should see, there we go. We're back to 4 worker nodes powered on. Now this VM is available, it says it's running. Not all the processes in it are ready, so it's probably installing all the necessary software in that node. So if I go here, we can see that the node has still not joined the class because it's not ready to do so. So if I run here, actually another command, you can actually see all the processes that are running every instance. And I think it was too slow because I think the node is back in. Yep. So in really few seconds, 2 things have happened when I deleted that node. On one side, Kubernetes is definitely detecting that the node is down, and it's going to remove that node from the list of nodes that are available for scheduling new pods and containers. At the same time, it's recovering the desired state by recovering and recreating those pods that were running in the affected node. But behind the scenes and at exactly the same time, BOSH has detected the problem. For BOSH, the problem is there was one node running. I didn't get the agent notification of it to be still running, so I'm going to remove it from my list of available and working nodes, and I'm going to create a new instance, and I'm going to deploy all things that are necessary for that instance to run. So in the time that it took BOSH to recover the VM and put all the necessary software in it and starting the kubelet and the kube proxy, Kubernetes had recovered the pods, and when all things were ready, the new node joined the cluster again. So we have, once again, the cluster fully recovered, all pods are running, or nodes that need to be running are available.